Good afternoon, guys. Is it audible? All right. Hey, why this many people are absent today? Only 10% of people have come. Not interested in studies. Interested in bad things only. Let me check the attendance once. How many are there? Wait. Who are there? Not how many. Okay, Abhishek, Aditya, Akash, Ganesh, Ankit, Abhishek, Vishnu Dutta, Lavanya, Manika, Masan, Narasimha, Narasimha, Reddy, Naveen. How many Naveen we are having in the class? Ba. 5 to 6 Naveen are there. Okay. Priyam, Rahim, yes, Amrita, Dikshatra, Shikshan, Shivkumar, Shavasalam, Shivraj, Sabir, Shiv, Vaishnavi. All right. I think people are getting the YouTube videos in night. That's why they're not attending live. Okay. No issues. I know that. That's why not coming. This is the problem with the generation. All right. So yesterday we had discussion on what we call the data structures and types of data structures, I guess. Respond. Okay. Did you go through the notes, whatever I shared? Yesterday's notes? If no, then please go through it once. All right. Is my voice audible, everyone? Okay. Yeah, what you are asking, you can ask. Let me see if it is worth of clearing in the class. I'll cover. Okay, we'll cover that. Yeah, I'll cover. I'll cover. Don't worry. All right. But for that, you need to have basics. Like, first of all, you need to find out the prime numbers. Na? After that, only we'll do that. Don't worry. I have that in this course. I'm going to cover that point because it is in the list of my questions. Okay. Yesterday we covered the data structure with collection concept, collection and map. Little bit idea you would have got how to create the collection of list, set, queue, and then how to make entries in the map. Correct? Which method is used to add element and all. Okay. Now, today we are going to start with some basic knowledge on complexity in the data structure. Why I am saying about complexity? Reason is that when you open Leetcode, let's say Leetcode, this do some problem. Now see, follow up. Can you come up with an algorithm that is less than big O of n square time complexity? Time complexity. Time though we know what is time. Complexity. What is this complexity? What is the use of it? What are the different types of complexities we are having? Is there only time complexity? If time complexity, then what are the different types of time complexity? All those things we'll try to understand. Is that clear? Today's topic is complexity. We'll get knowledge on big O notation, types of time complexities. What are the different other types of complexities? Time complexity, space complexity. All these things I'll try to cover. Is this clear? Okay. Now, if you are having friends who have not attended yet, just because maybe thinking today some boring topic will go, just do one thing, just ask them to join the class for today. Today's topic, very much important, the heart of the data structure, that is complexity. Now, what is this complexity, sir? Complexity means it will refer to the amount of resources, such like your time or the memory, on which the algorithm or the data structure will consume. Whenever the data structure or the algorithm is performing any task, what resource, how much amount of resource will be consumed, that is nothing but going to be given by time, given by the complexity. So there will be two aspects here. One will be the time complexity, another will be the space complexity. Okay. So before that, let me say what is complexity. So complexity refers to, let's say it refers to the amount of resources such as time or memory that an algorithm or a data structure consumes. When sir, when it will consume? When performing an operation. Okay, let it be linear search, binary search, whatever type of operations will do. Insertion of element, deletion of element, replacing the element, merging the elements, whatever operations we do, how much resource is consumed based on time and the memory, that one is going to be defined by the complexity. Okay, so basically here complexity involves two aspects. What are the two aspects? You already told me. One is time complexity and the another is space complexity. So the first question arises here, sir, what is this time complexity? We don't know. Okay, we'll see what is time complexity. Okay. Anyone tell me what is time complexity? That day some wrong answers I got, but I gave a correct answer that day. Time complexity means
Amount of time. Huh? Amount of time used to execute program. Is that a time complexity? Let us say, for example, you are using a mobile phone. This is your Android mobile phone. Okay. And here is your kidney seller phone. You have to sell your kidney to get this phone. iPhone with iOS. Here we are having iOS. Here we are having Android. Okay. Understand this point very carefully. Okay. This is very, very much important. No, that is the wrong that is the wrong concept. It's a little bit different. Now please focus. In Android phone, you are having nearly 1000 contacts. Okay. Same. You have got two phones. One is Android phone. One is iPhone. Okay. Getting Android phone is easy. Anyone can get. All right. Getting iPhone is little bit tough, but iPhone should be brought without EMI. I can see 90% of the people these days are buying iPhone on EMI. Even the auto rickshaw are also having iPhone these days. But what about the EMI? हाँ, मजा तो तब आएगा जब बिना EMI के खरीदो. You go to the iPhone store, you pay on cash, full cash. That will be the fun. Okay. Now leave about the iPhone buying and all. Now let's say, for example, you are having the time complexity. Sorry, you are having this Android mobile and you are having the iPhone. Okay. Now in Android mobile, both are your phone only. In Android mobile, you are having 100 contacts. Contacts means, person's name and number saved. Okay. Then in iPhone also, you're having 1000 contacts, not 100, 1000, sorry. 1000 contacts. Here also 1000 contacts. Now you open the contacts application. In the contacts application, there is a bar, search bar. Can you visualize that? There is a search bar in your phone. When you open the contacts, you're having a search bar. Here it is written type to search, type to search. Here you are going to search for one name. Here you are going to search for one name. Name is, suppose, let's say, what name you will save? You will save one name, suppose for some special person, today some special day. So I'll give the name as tension creator. I have saved a name as, suppose, tension creator. Okay, tension creator. There is someone who creates tension for you. So the name is tension creator. Now you are searching for this tension creator in Android. When you search for tension creator, you are searching this tension creator in Android. When you are searching, let's say, for example, it took nearly 10 millisecond. 10 millisecond. Okay. Now you search the same in iPhone. It took nearly 6 milliseconds. Because searching happens very fast in these phones now. In milliseconds, we got the contact. If it is available. If not available, that is another case. If available, here also 1000 same contacts. In iPhone also same 1000 contacts. Everything copy paste, nothing here and there. Everything same. Same name, same mobile number. No extras. But in Android, when you are searching for tension creator, it is taking 10 milliseconds. In iPhone, it is taking 6 milliseconds. Now tell me, which one is having higher time complexity? Which one has got higher time complexity? Everyone, respond. Use common sense and respond. In which side we have higher time complexity? If you'll not respond, I'll not continue. Everyone, respond. Still more people are there. Still more people. Everyone respond. I want everyone's name here. Still there are people. Hey, everyone, respond. Sleeping somewhere? Huh? Or keeping phone aside and enjoying the day? Very good. Nice. Okay, no issues. If you're not able to decide, no problem. No issues. At least respond something. Yeah, like you know the answer, you don't know the answer, whatever it is, respond. Don't be dead here. Very good. At least someone is very much honest in our batch today. Not able to decide. Very good, beta. Nice. Now, whoever said Android, there are lot of people. Nearly everyone said Android. Some people are saying iPhone. So the people who said iPhone is having more time complexity. Wrong. Now the people who said Android, that is also wrong. Android also wrong. Viva, Dabba fellow, what he is saying? Time complexity is wrong both sides, and not Android, not even iPhone. Then who is having more time complexity? Time complexity is not the amount of time that is required. Getting it? Time complexity is not the amount of time required to do this task. Okay. Time complexity is not is equals to time taken. That is the main rule of data structure. That is where you need to change your mindset. Then what is time complexity, sir? Time complexity measures how the execution time of algorithm will grow relative to the input size. Bigger input you give, bigger will be the time complexity. Understood? By chance, I would have said that here in place of 1000, I'm having 1 lakh contacts. And then suppose 6 milliseconds, then also this fellow would have got more time complexity. Reason? Input is more. Where you are searching, you're performing operation for searching the contact. If input size is more, then the time complexity is more for the operation. Keep that in mind. Who turned on this AC? 1 second. ये एसी का रिमोट यहाँ पे खुला था, कहाँ चला गया था? तो बंद किया करना. All right, sorry for the disturbance. Now come back everyone. So what is time complexity? Time complexity is not is equals to time taken. It's never like that. Then what it is? It is the measure. It is the measurement of how the execution time of an algorithm will grow with respect to the size of the input. So it will give you some estimate of like nearly how long an algorithm will take to run or to execute when the input grows. Okay, that is time complexity. Searching for some element and finding the element faster, that is having time, that is not time complexity. That is wrong concept. Completely wrong concept. Time complexity is not equals to time taken. Time complexity completely depends on the input, not on how much time required. Got it? Visualization has to be changed. So what is this time complexity? Time complexity is from now onwards. Keep the definition like this. If interviewer asks you, tell me about time complexity, you should say, it measures, not it. Let's say better why to use this articles here. Let's say time complexity. Time complexity measures how the execution time of an algorithm how the execution time of an algorithm or operation grows with respect to or relative to the input size, with respect to or relative to the input size. Try to understand the statement. Okay. Now what it gives? It gives us an estimate, just a rough idea, not exact. It gives us an estimate of how long an algorithm will take, how long will an algorithm take to run as the input grows. Okay, this is very much important point. It is not as the time taken. It's not about time taken directly. It's about how much time the algorithm will take if the input size is increased. If I increase the amount of input in the data, then how much time will it take to execute that algorithm? That is time complexity. And this time complexity is generally expressed. It is often expressed using big O notations. What is big O notation? We'll see. Okay. Now, what are the common time complexities we can get? Examples are, let's say, big O of 1, nothing but n. Then we are having big O of log n. Then big O of 1 is not n. This is different. This is the constant time complexity. Next, big O of n, linear time complexity. Then big O of n log n. Don't ask me mathematics now. Okay, you don't know what is logarithm and all, Baba. Repeat class 10th. We are not here to learn mathematics now. Big O of n square. Big O of 2 to the power n. These are the most common time complexities you'll find in Leetcode. Now, some people will come with a thing that, sir, theory of computation we did in college days. There we saw big O of n square plus 2n plus n square. What is the time complexity? N square is the time complexity. Big O of n square, that is the time complexity. Always reduce the constants. Okay. That's the shortcut I can give to you. Don't start theory of computation here. Not possible. We are here for Leetcode, not for theory of computation. Okay, na? Those things, if you want, separate workshop, I'll start one day. Not now. Please focus. Now, big O of 1. This is termed as first learn the term. Big O of 1. This is constant time. Big O of log n. This is your logarithmic time. Logarithmic. How do we write? Logarithmic. Logarithmic. MIC. Logarithmic time. Big O of n. Linear time. Input increases, size increases. Sorry, time increases. Linear time. Next, big O of n log n. This is your log. What do we call it? Log linear time. Then big O of n square. This is nothing but your quadratic time. Then big O of 2 to the power n. This is exponential. First, accept this much. Understanding, sir? Accepting the points here. Now, sir, tell us, sir, when we will get this constant time, sir, a big O of one, sir, not understanding it. I also don't understand. Accept the point which I say first, after that you will understand. I am also new only. I don't know Java only. Think like that. I also don't know Java. You also don't know Java. I also don't know data structure. You also don't know data structure. We are Dabba here. Okay? Listen. Babu Ranjit, from where you are not understanding, beta? Tell me. Which one you are not understanding? Explain with example. Arey, Sunil Babu, explain with example. We are about to start example, sir. Little bit patience. My class means patience. Time complexity you didn't understand. I gave one example. Na? Ranjit, where are you from? What's the full name? Ranjit Sahu, I guess. Andhra. Okay, Ranjit. This is different Ranjit. One more Ranjit was attending. Ranjit Sahu. Okay, beta. Not understanding. What not understanding? I gave one example of Android and iPhone. Were you there when I explained this example? Yes. Then what you didn't understand there? Huh? Here you are searching for some contacts. Here also searching for some contacts. Same context, same logic, everything background. When we are searching for your name, background, some logic is happening or not? You think once. Think like a IT person and tell me, when you are searching for your name, any name, some background, some coding is working, na? Some code is working, some algorithm is working. Same algorithm is here also. Same names, same algorithm, same data you are searching. Here 1000. It depends on algorithm. Yes, sir. Yes, correct. Now you are coming to the line. Yes, correct. It depends on it. Correct, sir. Depending on input size, how much input? Correct. If input size increases, time complexity also increases. It's completely dependent on the input size. How much input is there? Generally, in the programming classes, what we do, we are taking small bacha numbers, 5 numbers, 10 numbers, 20 numbers, 50 numbers, max like that. But in real time, you will not work with 10 or 20 numbers, na? Or 10 or 20 names, 10 or 20 data. In real time, there will be millions of data. So never ever think time complexity with comparison to small amount of data. You take time complexity with comparison of small amount of data, you will never get the concept. You have to think that when there is a huge amount of data, what will happen? How the algorithm will work? How much will be the complexity that time? The more amount of data I increase, how the time complexity changes. That one we have to understand. So let me give you some examples. Let us say, for example, I'm having constant time complexity. What does this mean? Constant time complexity. Constant time, big O of 1. Big O of 1 is called as constant time. Like for example, first accept. Acceptance is very much important. Acceptance is very much important. You will not accept, I can't do anything. First you have to accept, you have to believe. Now when I will say this is a tree, in reality it's a tree or what? Just a diagram representation. Na? We visualize, we accept, okay, something structure like this tree, okay. Later, slowly realization will come. Na? Same way, first accept this fact. Okay, please don't make yourself confused. Everyone, I know this, like how you guys are feeling now. Please have some patience. Let me complete. Don't give your answers. Now, constant time. Big O of 1 is the constant time. What does it mean? It means execution time does not depend on the input size. Hey, sir, you said input size required. Array, real time complexity when we discuss, proper time complexity is nothing on input. Sorry, it is nothing about the time. It's about the input size. But when I say the type of time complexity big O of 1, this is a constant time. Let's say, for example, suppose I will say, write a program to store elements or write a program to display elements present in an array. Okay. When I say write a program to display elements present in an array, that time you guys are going to get the constant time. Okay. How, sir? Let us say, for example, I'm going to have one array. Let's say, wait, I'm having an array. Int ARR is equals to 10, 20, 80, 50, 30. Let us say these are the elements. 5 elements I have stored. Just for your understanding, I can't give big data, millions of data I can't type here now. That's a giving small data now. Just accept it. Okay. If I will say you system.out.println and I will say array of 4, how much time will take? Whatever amount of time will take. Now you'll say, sir, how will I understand how much time it will take? Array Baba, visualization. Here is an array. Visualize. There is an array. Dabba, big dabba, dabbe ke andar dabba here. 10, 20, 30. Hey, not 30, this one. This one is 80, sir, not 30. 80, 50, and 30. Last one I'm taking 30. Okay, now let's see. Now every array cell is having some index. 0 starts with 0, 1, 2, 3, and the last is number of elements minus 1, that is 4. Now I will tell, when in front of your eyes you're having this memory, I will tell you, go Babu, get the array of 4. You'll run there directly, you'll say, 30 is there, 30, 30, 30. Okay. Then I will say, go better, go and get array of 2. You'll Fatax will reach here and you'll say, okay, array of 2, 80. Now you tell me, are you searching anything here, sir? Are you searching element? Are you comparing anything here? No, no comparison, nothing is done. Whatever amount of time you take to access the element present at array of 4, same amount of time you will take to access the element present at array of 2. Correct, na? Are you able to get it? Whatever amount you are taking to access the element present at at index 4, same amount you will take to access element present in index of 2. Why, sir? Sir, I will search na, sir, 0, 1. Are human being, why you are searching, re? Why you will search? Why you will search here? You can see na, in front of you only it is there. But actually take out na. When everything is there in front of you, why you will keep on searching? You want to waste time? You don't want to waste time now. When you see that these are the indexes, I can access them easily with the index. So why to worry? In this case, the time complexity is big O of 1. Then also, take huge data, then also. You are having the indexes in your hand, na? Fatax will go to that index, na? Directly will go there. Why will keep on searching index again? Just let me know one thing. This array you are not understanding. Let me take some real-time example. Now today is a nice day. I thought of not giving this type of examples in online sessions, but what to do? Generation is like that. Until and unless I give kachara examples, this generation will not accept the answers. Technical terms, your generation not ready to receive. Okay, take comedy terms. Don't take it in an informal way. Just for people's understanding, I'm giving this example. Whenever people don't understand technical terms, I give them the girl terms, boys terms. So don't judge it. Just accept. Today is one nice day, due to which I can see many people are not there, expecting that they will attend the class, recorded class. Okay, everyone is aware of this day. For us, that is not Valentine. For us, that is Valentine. Different concept. Okay, now see. Now, suppose, for example, this is your friend. This is your friend. Your friend saw someone. When he saw someone, his eyes Too much big now. Yo, so much nice one, nice one. He saw someone here. Okay. Knew someone came to the area. This is someone nice, beautiful. Okay. Some lipstick also, you give red lipstick. Okay. Now your friend saw. The friend fell in the worst thing in the world, which your generation are following every time, even if I'm telling not to fall on it. Now, after that, what happens? Wherever you go, we follow Vodafone. The friend will become Vodafone SIM, na? Not Vodafone SIM, that pug. You know that Vodafone, one advertisement was there, Vodafone Hutch. One small dog was there, no? Wherever you go, we follow. You remember that pug? Your friend will become like that. What he will do? Wherever you go, we follow. He will do like that. Network follows, correct? Now, first day he went behind her with his bike. Girl is going on her daddy's gifted helicopter or the aeroplane, whatever she got, Scooty Pep. Girl is going on Scooty Pep or Activa, the helicopter given to her by her father. Let's say Scooty Pep or Activa, on which the girl is riding. Boy is going with, let's take one chapri one, that is Duke, okay, on which he has written Mummy ka magarmach. Now, this is Daddy's little princess. This is Mummy's magarmach. Now he is following her. Why he is following? He wants to see that where the girl lives. Let's say the girl is living in this colony. This colony has got multiple houses. Among the houses, there are some gully also. The alley, gully, houses are there. All right. Now, first day, the boy followed her. He got the house address. Yes, sir, no, sir. Tell me. Hey, online people, respond, Reba. I'm giving nice examples to you, you're not responding. Your generation likes this example and then you're not responding. Reba, what I'll do now? Shall I jump from the table or what? Respond, everyone. Simply not responding. Chalo, very good. Now here what is happening? There are different houses, and you know every house is having some sort of like house number. Now this lady, this daddy's little princess, she is living somewhere in this house. This one, this small and sweet house, home sweet home. This house has got some address or not, Rabba? Street number this, house number this, falana dimkana. Something address is there, na? Now this boy has followed the girl. He knows this colony. Tomorrow, when the boy has to go to this house, suppose, let's say, for example, tomorrow patch up happened and they started talking with each other. So at night, like 2 o'clock, when the whole world is sleeping, he's awaking like a owl. This girl also awaking like owl, and she says, "Bangaram, Bangaram, want to see you now." Then boy, what to do? Boy, men will be men. Took a bike, taxi reached here. Now tell me the situation. Feel the situation about the boy. Will he keep on going and think here? Where I will go? Where I will go? Will he do there? No, he will go like rocket, directly reach here. Why he reached there directly? Tell me. Why he didn't go and knock the another door? Tell sir. You just feel the situation and tell. Why he will go to this house directly? Why he will not go to any other house? Will he keep on going on every house? Knock knock. Daddy's little princess there. Knock knock. Daddy's little princess there. Will he do that? Whole colony will beat him. He knows exactly where she lives. Similarly, Rabba, similarly, whenever there is an array, in the array, indexes are there, na bata. So your system knows now where it has to go. So one, huh? When you are going to fetch element directly from the index, why you are taking tension? What is there to understand now? Whatever time you will require to fetch this one element at 4, same you will require for element at 1. Because let's say, for example, today one girl, that is little princess. That is little princess house. Tomorrow, this is a chapri fellow, na? I told na, he's riding Duke, chapri only, wasting his life. Tomorrow another he will see. Ek gai, dusri ai. He sees the another one. When he sees the another one little bit more stylish, walking like Kamaria Lachka here. Now he'll follow her, na? Same colony, but different house. Now she says, oh, baby, missing you. Come fast. Okay, Fataks will reach here, na? Will you get confused? Oh, yesterday night I went to another house. Today I'll go another house. Babu, he will get beaten, na? He knows the address, na? Similarly, your system also knows these indexes, na? So why taking tension? Whatever amount of time required to reach at this position, same amount of time required to reach here. It's not about jumping from here, then here, then here, after that finally here. It's not like that. When I'm saying system.out.println array of 4, means directly go to this here, this position. If I say array of 2, directly go over here. You know the index, na? Ardhamaindi sir, understanding. Odia people. Bujucha. Hindi people, समझ रहे हो? English people, are you understanding? Telugu people, Ardhamaindi sir. Which other language shall I say now? After that, I don't know. After the Ardham, Indhun, I don't know that. Marathi, I will learn soon. Okay. Hey, you guys understood this concept, this time complexity, constant 1, fixed. In real time, data generated dynamically. Array, Babu. Data generated dynamically, huh? Right. After storing elements, then only you will fetch the data, or before storing element, you will fetch data? Eh? If more data, how we will give the index? Array, Baba. Particular element at an index I want, beta. Again, you are searching. Change your mindset, Baba. Change your mindset, beta. I said, na, change mindset. Don't search. Data is there, na, ready there. Let it be 5 data, 5 million data. Indexes will be there. You are accessing them with the index, direct with the address. When you know the address directly, you'll go to the address directly or keep on roaming here and there. You tell me. When you're having complete map in your mind, when you're having complete map in the mind, which location, which house is there, you will go directly to the house or you'll keep on knocking everyone's door. You will say, baby, are you there? Someone's father will come, he will give you baby nicely. Again, another one will go, baby, are you there? The whole colony will beat you there. When you know the address directly, why you will not go? Here you'll go directly. Na? So what is there to think again? Now, still not understood, tell me, I'll give another example. Babu, did you understand? Shall I give another example? Hey, Baba, my talking is like joke only, right? Don't take it another way. It's a joke. I'm not scolding anyone here. I'm not scolding. You can ask, don't feel hesitated here. Take the jokes as jokes only. There is a fixed, na, that's why we know the index. There is a fixed. Beta, structure is fixed, na? You get an array. Dynamically also, if you enter the elements, once all the elements are set, after that I am accessing, na? You're saying like this. For for the small also, you guys are getting confused, means how you guys will cover up everything, right? I is equals to 0, I less than ARR dot length, I plus plus. Here dynamically elements are entered is equals to SC dot next int. What is this SC?
Somewhere someone created scanner. Don't ask me now again what is scanner and all. Don't ask me now. I'll explain that one some other day. Okay. Now here, dynamically you enter the elements na. Tell beta. Let it be 5 lakh elements. Dynamically you are entering. After this work only, after entering all the works only, once all the elements are entered, after that only I am saying, get me the element present at 4. So you know na, how many indexes are there after this. Once the elements are entered, after that your system knows or not how many indexes are there in that memory. Then searching for the element is there or accessing element is there. I said search element or access element. Tell me, sir. Is it about searching or accessing? Accessing. When you are accessing the element based on index. Accessing element, not searching. Accessing element based on index. In that case, the time complexity will be big O of 1. So it does not depend on the input size. Whatever is the input size, let it be 5 crore elements also. You know the address where you have to go, directly you go there. No need of searching. Did I reach? Not required. Directly go there. Understanding, sir? Okay. Anyone not understood, please ask. Akash, are you clear? Pavan, are you clear with this concept? Pavan, Naved, Mr. Sunil. See the video now then. Net problem then see the video in the evening. Last जो कोई बुझेलानी कौन बुझेलानी रे अरे मौसा ये रे कौन पिला रे तम मने okay okay sir okay. Big O of 1 means constant time. Constant time means time is fixed. Okay, sir. Whatever amount of time required to access element at the last index, same amount of time will be required to access element at any index. Yo, let me write. Whatever amount of time required to access element in an array of size 5, same amount of time required to access element in an index with array of size 5. Same amount of time required to access element in an index with an array of size whatever element. Why, sir? Because we know the exact address. We are not searching anything. We are just accessing from the index. Read this one once, and then you tell me you understood or not. The people who got internet problem, did you understand this one, beta? Okay. Hmm. So, in technical term, what is the conclusion? Conclusion for this person, someone kill this person, right? Beta, you are from IT background, non-IT background? Non-IT. Okay, beta. Why your mind is saying that you have to search again and again? I am saying no need to search, beta. I said an array. Did you attend array sessions or not, beta, from me? I told an array concept. Huh? Multiple arrays are there. There multiple elements are there in the array. Multiple cells are available. Whatever number of cell, I don't care. Everyone is having some in. You will go for searching. Beta, why will you go for searching? Tell sir. Will you go for searching anything or directly you'll reach to the address? Change the thinking process. When you know the address, you will go there directly, na. Even if lakhs and crores of elements are there, you'll reach there, reach to the exact address directly, na. If I say array of 6, will you keep on searching where is 6, where is 6? No, not directly you reach there, na. Because you know already where is 6. It's already created in your mind. This is in your mind. When I say array of 6, directly you reach there, na. You don't go for searching. We can access directly with index, same statement 100 times. Why not listening? Statement also written. Use your brain. Yeah. Accessing the elements. You are another level. Leave. I'll not go to the doubts now. Wait. People are asking unnecessary doubts now. 5 minutes you wait. After that, I'll come back to you. Accessing the element from an array with the index is constant. Time complexity for accessing. Time complexity for accessing element from an array with the index is constant. Okay. That is big O of 1. It is fixed regardless of the size of array. Accept this point first. You are not searching or anything, Rabba. How will you not know? You tell me, how will you not know the index? You are giving the index here, na beta.
Mr. Satya. Babu Satya Sai. We are giving index na beta when we create array. Index is there na beta. Array is already ready na. Array prepared na. Eh? Already set na. Then why to take the tension of searching? Why you are searching thinking again? Don't know about index. Now about searching. Don't give extra operation. You'll get confused if you give extra operation. All right. Now can I just say everyone has understood? Okay, chalo, let's continue. So constant time we understood. Let me just make a list of time complexity first, then I'll give the notes. Wait, hold a second. Now what I will do, I'm like that only. What I will do. If anyone has not understood means I can't digest. I get mad. I can't continue by keeping anyone behind. I can't leave anyone. I feel very bad. In my school days, I used to face this problem. My all classmates used to understand everything. I was looking like, what the faculty is saying, I'm not understanding because my brain was not ready to accept. I was overthinking. That's how I was always coming last. And I didn't get the, what do we say that? Get the chance to ask to the faculty. Whenever I used to ask them, they used to scold me like hell in front of everyone. Earlier days, we were getting punishments. So I feel it. That's why I explain what to do. I'm like that only. If one student will tell that I have not understood means, I'll keep on explaining. What to do? These days, brain is not braining, sir. Because in brain, someone is dancing these days. Keep the dancer out of your brain when you're coming to the class, everyone. Otherwise, your brain will not be braining. Correct. Akash said correct only. Very good. Okay, chalo, let me continue now. Now focus, Babu. All the overthinkers. Don't do the same mistake which I used to do in my school days. Focus. Don't overthink now, I'm telling. Overthinking will do means gone, Babu. I can't explain after that. You will die only. You will die overthinking only. Small bacha brain is there. That also giving so much load. Aram you can understand. Unnecessary overthinking. Now let's see. We are having next thing that is logarithmic time. What is this logarithmic time? Logarithmic time means, let's say for example, earlier we had one example of searching name in mobile phone. Now I'm not having name. I'm having, yeah, I know they can get the recordings, but what to do better? If someone will leave my batch without understanding means I can't accept that. They came with a hope now that they will understand. They're thinking that yes, one faculty is there, he will make me understand. If I will not help them means they will never believe on any faculty in the world. That's why I'm explaining. I'm sorry, I'm wasting other people's time. But what to do? I have to support those people also who are coming with a hope. At least they're trying a little bit. If I will also do like other faculties, I'll just scold them and send them away means it's not good, na? Who'll take care of those papam fellows? Okay, I'm so sorry, guys. Wasting your time for unnecessary things. Please adjust. Your karma is like that. You came to a person who will not leave the student. Okay, now please focus. Earlier, we searched for a name in a mobile. So some algorithm is there, fatapat, some searching happened. Now, there is a dictionary. You know dictionary? Very good. Thank God. If every faculty like you, then cracking UPSC also nothing, sir. Okay. I wish I could get a faculty like me in my days. Okay, now focus. There is a dictionary. In the dictionary, the big dictionary. Thousands of words are there. Thousands. How many thousand? I don't know, but So many words are there. Now I'll ask you to search for a word. Let's say the word is called as sort. The word is called as sort. Search this word in this dictionary. What is your approach? What you guys will do? Don't think like developer or programmer. Don't show your talent right now with a developer or programmer mindset. Normal human mindset I'm asking. Don't become chitty in front of me now. I'll give virus otherwise to your brain. Don't become chitty or robot. Think like a normal human. What you guys will do? The first thing what you will do? What you do for the first time when you get the dictionary to search a word? Think that situation. Don't become developer here. I'm telling, don't become developer. Still now I have not got the correct answer yet. I'm telling normal thing, ba. What you doing, Ray? Asking you normal question, that also making critical. Sir, I'll go alphabetically. Arey, ba, alphabetically you'll go, you'll die. Here, another person, Ray. Index file go, Ray. Done. You guys, I got it. You are ultra level Rajnikant, you are. Wait, what you will do? For the first time, when you get a word, you are standing here. You hold the dictionary in your hand. After that, you open the dictionary randomly, na? Correct or not? Why you are opening randomly, sir? Reason is there. In the dictionary, the words are already sorted. Words are already arranged. In alphabetical order, the words are already arranged. So what is the first approach? You will open the dictionary into half, or maybe not in half. Let's consider half. You'll just randomly open the dictionary. Let's say dictionary is opened. Dictionary opened now. Okay. Dictionary is opened. When you open the dictionary, you will see here, na? In this complete page, you will see which alphabet I got. Did I get alphabet S or I get any other alphabet? You will see now that one first. If it is not the alphabet with S, if it is the alphabet with G, then what you will do? If it is the alphabet with G, what you will do? You will go to right hand side or you will go to left hand side? Tell me. Everyone. If the word that you are searching is sort, but you open the dictionary, you found out words starting with G, you'll go to the right half or you'll go to the left half? Left half, na? People are there. I knew it. Right, left also people don't know. You'll become developer. Pakka you'll become one big developer. You'll go to left hand side. Pedda developer will become. Complete mad only, Rabba. You'll obviously go to the right hand side, West fellow. Using brain or using your knee? Huh? Your brain is on your top floor or went down to the knee? You'll go to the right hand side. When you go to the right hand side, again you will take it and put it in half, na? And then again you will search. Again, not search, you will visualize here. You will just see. Let them make fun. After that, one day I'll make fun. That time they will understand. I'm telling, I'm just taking students seriously because I feel like students are not understanding. If you are thinking you are here to waste the time, please leave this batch. Because I know I'm wasting a lot of people's time. Hundreds of students are waiting just because of one person's wrong statement. Everyone is waiting. So if you are thinking that you are going to waste my time by giving wrong answers or wrong comments, please leave, Rava. You don't know my patience level. I have a lot of patience level. You keep on asking me same question, I'll keep on repeating. Whole batch will leave, but I'll not leave you. you don't know about me properly, you go and check in my batches, offline batches. Go and ask who is Jagannath. They'll tell you how much stubborn I am for students, how much serious I am. If I feel someone is not understanding, I'll hold that fellow. Until you understand, I'll not leave you. If you're thinking you're going to waste my time, then please exit from now only. I don't care. If 2 people are there in the batch, then also I'll explain. But I need serious students. Unnecessary drama you do, exit Rabba. This is not like any other YouTube channel or anything that will come and waste our time. We are here to study. Faltu kachara thing doing. Okay, now everyone, please focus. What we will do here, we'll make the dictionary again into half, then we'll search again. Here we will see now with the eye, we'll run our eye here. Is the word available, not available? So the letter is available or not? If not available, again make it into half. Slowly. Sometimes you will find that word starts with S. After that, again you will start searching in a alphabetical order only. You'll keep on searching now. At some moment, you will reach to the half. You'll reach to the half where there is no more thing to search. This is the shortest way you can get. But there is another way where people said, from the first page, every word I will search. Let it be thousands and thousands of words. I'll take my word. I'll take this word sort and I will start from the first page until I get the word. I'll read every word. Don't you think so? Too much time is required there. Too much of time will be wasted, na? Now, logarithmic time means, just now one example we took, na? We took the complete array, nothing but the dictionary, into half. Why made it half? So that we can reduce the number of execution. Okay. We are going to find the element in a sorted array, in a sorted memory, where the algorithm will cut the complete program in half. In every step, it will cut the program in half. Not the program, the memory in half. Okay. So what is logarithmic time? Logarithmic time is nothing but big O of log n. When it occurs when the algorithm cuts the problem size in half at each step. In every step, it will cut into half until it finds the element, until it reaches the operations result. Okay. Example such as just now we did that searching, na? We cut into half, then search, then cut into half, then search whether it may be in the left hand side or right hand side. That algorithm is nothing but your binary search algorithm. Okay. So binary search is a very much efficient algorithm only when elements are sorted. If not sorted, gone. Okay. The array is half. The dictionary is made in half in every execution. So in that case, the time complexity will be termed as big O of log n. Okay. Then one more search algorithm is there in which you start searching from the starting to ending. Starting to ending, if you are searching, means maybe element is found in the beginning, maybe in the mid, maybe in the end, maybe not found. Unnecessary execution wasted, time wasted. That is linear search. We don't follow linear search. Linear search we will follow only when we have unsorted array. But if you are having sorted array, never go for linear search. Now I'll say, sir, I will sort and then I will search. Okay, your choice. You sort it, then you search it. Easy. Right. Now, what is the algorithm for binary search? What we will do, sir? Easy thing. Take the array, cut into half. To cut into half, you need to get the middle element, the middle index. Then you have to think of the last index, nothing but the left, and nothing but your right index. nothing but the another half. Okay. You have to take it into half. Works on sorted on. Yeah, very good. Now what will be the algorithm? Algorithm will be something like, let's say we'll take one method. What happened here? Take some method, public static void, or let's say I'll return the element. Public static int. If element is found, suppose element is found, then I will return like where it is found. If element is not found, I will return minus. Okay, that is my algorithm I'm going to design. I'm going to return the index where the element is found. If not found, then I'll return -1. So now public static int binary search. Binary search for an array. Array is int arr, which I'll receive. Then what I want to search? I want to search for a target. Okay, so initially I'll take some indexes. Let's say left index is equals to 0. Then I'll take for the right, let's say right is equals to array dot, whatever is the number of length, -1. First index, last index. First index 0, last index right. Okay. Now you will take a support of loop where you will say that the left index is less than or is equals to right index. There's another way also you can say where the first index and last index both are not same. Then also it is working. Now I will say the mid index is equals to the left index, the left half. Sorry, the first index plus right minus left by 2. This is one way. Making the array in half. Then we need to check. We need to check if the target is in the mid. Maybe when you open the book, the word that you are searching is in the mid only. In that case, if array at the mid is equals to the target, what I will do? I'll directly return the index. This is nothing but your, here we go of log n. Okay. Sir, if suppose your target is at the mid, you wrote that logic. If the target is greater, then what you'll have to do? You have to ignore the left half. So I'll say if array of mid is less than the target, then in that case you will say that the left is equals to mid plus 1. Else you will say, else means obviously target is smaller. So you will say right is equals to mid -1. If none of the thing is there, nothing matching here, sir, what you will do? In the last you will return -1 if target not found. Simple story here. Code you didn't understand. Now you take array. Here we are having 10 sorted array. Okay, unsorted is not going to work. 20, 30, 40, and 50. Now you want to search for 70. Your target is 70. Don't think like human being now. Sir, 70 not there. Don't say like that. Think like a computer. How you will tell the computer to search? Computer may search from starting to ending, or computer may search it in the half. What's the best way? Take the array in half. As it is sorted already, take the array in half. If you make the array in half, how will you get the half? Starting index is 0, last index is 4. 0 plus 4 by 2, how much you'll get? Starting plus last by 2. 2. So 0, 1, 2. So this is your mid. This is your mid index. This is your mid index. This is your first index. And this side is your last index. Think this story. Try to understand the story now. Don't go with this code now. Don't go this side. Don't go this side. Don't look at here. Don't look this code. Don't look at the code. Now focus this story. After that, you can understand this level of coding. Okay. Now, I need to search for a target. The target is 70. So what you will do? First, you will take the array into half. When you got the half, you found here. In the half, we got 30. Now you'll say, sir, suppose there is one more, sir, here 5, sir. 0 plus 5 by 2 is 2.5. I will kill you if you say like that. 2.5 will not use here. We are dividing integer and integer, so answer will be integer only, okay? Now what you will do? Middle is nothing but 2. 4 by 2 is 2. Okay, what is there? 30. Compare 30 and 70. Mid and the target are the same? No. Now the target that you have got, that target may be present in the left hand side or may be present in the right hand side. Any side it may be present. Now you can see it is a sorted array, sorted in ascending order. So what I will do? I will ignore this. I will ignore this half. I'll ignore it. How to ignore it, sir? First index to 0, na? Array first index I set as 0. I can change the first index, na? I will say first index is equals to, if the element is greater than the, if the target is greater than the middle index element, then first index is equals to middle index plus 1. That means now this is your first index. And then next time when you continue the story, what will happen? Your story will contain only these two elements, na? 40 and 50. Why it will contain only two story? Array, I'm accessing elements based on first index, last index, mid index. So here is the first index, last index is this one only. Then again this one half will happen. Then this one you'll get. One by two is 0. So 40 you get. This is only will become the first index. And here you're not finding element. So again you can't make half. So what will happen? First index, last index, both are going to be same. When the first index, last index both are same and you not found the element, that means what? Element is not present. By chance found means element is present. If matches, then element present. If not, then not present. This is nothing but your binary search. This is what we converted into code. And in this way, when the array is broken into half, the time complexity will be big O of log n, nothing but the logarithmic time. So when you're having big data set, big data you're having, in that case, never ever choose the linear search. Always choose this algorithm, that is binary search. Understanding? Oh, everyone. Sleeping or what? Did you understand? Okay. Next. Meaning understandable, code not understandable. Practice the code, you'll understand. It will be in the recording. Do the dry run. I told you, no, always do the dry run. Do the dry run of the code. You'll understand after that. If you'll not understand, ask me again tomorrow. I'll explain it with the dry run by my own. I'll write a program in front of you and then I'll do the dry run. Okay? Got it, Vaishnavi? All right. Okay, chalo. Next.
Next is the linear time. What is this linear time, sir? Linear times means the more input you give, the more time required to complete the task. Okay. If there are 5 elements, suppose here, suppose there are 5 elements. Think like this. 5 elements are there. Index 0, 1, 2, 3, 4. Okay. Now elements are there 10, 30 or 3, 40 or 14, anything you take. Here 70, here 20. Now I will ask you to search for one element. That's the element is 7. Search for 7 here. What you will do? Suppose the old process that some people suggested, start from the beginning. Start from the beginning means what? Here, go and check. Is element present? No. Element 7 present? No. Element 7 present? No. Everywhere you are going and knocking the door and checking, hey, 7 there, not there. So here the element is not present. So it took like nearly suppose 5 milliseconds. 5 milliseconds to complete the task of searching 7. At last you found that element is not there. Suppose these elements are, total elements are 1 crore elements. There are 1 crore elements. And you are searching for 7. So what you will do? In every cell you will go and check, na, 7 present, not present, present, not present, present, not present. Here 5 elements were there, 5 milliseconds. 1 crore elements are there means 1 crore milliseconds will take. Maybe element will be present, not present, who knows? So with respect to the input size, if more input is there, then more time it will take. So it is the time complexity is raising with the input size here. Okay. So it means what? Here in linear time, it means the execution time grows linearly with input size. The more is the input, the more time it will take to complete the task. This is your linear time. What's the example? Example is nothing but your linear search technique. How do we design the linear search technique? Simple, sir. You got an array. For that array, let's say public static void linear search for an array with some target. What we will do? Let's start a loop. For start with the beginning. Int I is equals to 0. I less than arr dot length. I plus plus. Now you will check every element, that element present at the index I, is it equals to the target? Knock it and check. Knock every door and check. Hey, target available there, like that you have to do. By chance you find the target. What you will do? You'll update something. Let's say boolean is found. Initially is found is equals to false. Now I will say is found is element is found becomes true. Once element is found, will you keep on knocking other doors?
Once you get the element, will you keep on knocking other doors? No. Why you will knock the other doors? You'll stop. To stop, you're writing break. Got it, sir? This is nothing but your linear search algorithm, where the time complexity is big O of n. N is nothing but the input size. The more input you give, the more time it will take. Got it? Next, log linear time. What is this log linear time? Simple. Log linear time means how do we like time complexity here? What will happen? The time complexity involves a logarithmic part combined with a linear part. So basically, what happens is in this type of like logarithmic linear time, the algorithm will divide the problem into smaller portion, and then those smaller portion again checked, again further processed. It is just like there's a big thing here. Break it into small pieces. After that, you got a small piece. Again, then break into small pieces. Then again, you got a small piece. Again, break that small piece into further process. Just a process you'll do. So what happens here is this is generally coming under some kind of sorting like merge sort, quick sort. There you get it. Okay. So merge sort means you don't know means merge sort means what will happen. First you have to divide the array into two halves. Then you have to recursively sort each half of the array. Then you need to merge the two sorted half. That is merge sort. I'll explain that. Don't worry. Merge sort algorithm also I'll show. Okay. Now. Yeah, correct. Class will do that. Now when it occurs when the time complexity involves a logarithmic part. Logarithmic part will come when you divide the array into half. Okay, na? Don't forget that just now we did logarithmic part. If you divide the memory size, if the algorithm cuts the problem in half, then you get the logarithmic portion. Don't forget that, right? Don't become super gajni here. All right. So when do we get this log linear time? It occurs when the complexity involves a logarithmic part combined with linear part. Sequentially, I'm not jumping here and there. Linear we have already seen, logarithmic also we have seen. Now combining them to get this big O of n log n. Nothing but log linear time. Okay, what does it involve? It involves, or let's say, well, let's say it involves. It involves algorithm. It involves algorithm. It involves algorithm that divide. It involves algorithm that divide the problem into smaller chunks and process each chunk such as merge sort. Even quick sort will also come under it. Okay. So here what happens, sir? Here, let's say, one second. Let me maintain some spaces here for better notes. Now, in n log n, in n log n, what does the n represents? N represents the input size. Sir, both the side n, here also n, here also n. This one also n, this one also n. Which n, sir? First one. Okay. N represents the input size and log n, you will get this log n by dividing. Like I can say log n arises from dividing what? Dividing the problem into half. Okay. This n will be like, further if I say, we can say the n will come from the recursion of splitting. And this linear part will come from processing. Each splitted part you are processing. So from there log n is coming. Got it, sir? Able to digest it or not, right? Sir, little bit about merge sort. Merge sort algorithm. What is merge sort algorithm? What you have to do first? Divide the array into two halves. Okay. Next, what you will do? Recursively sort each half. Then what you will do? Merge the two sorted halves. Is this clear? How to do that? We'll do that tomorrow. People are not able to digest now. Whenever, what did you say? When do we? No, there will be no offline, sir. One second, just missed some comments. Mat.round we need to add in the line number. No. That round and all is not required, beta. We have to avoid the float value. Not required. Automatically, when you are dividing two integers, obviously answer will come in integer only. But code is not understood. Code understood. Takes more time. Null registered. When to use? Okay. When to use the merge sort? How will I say, like, when to use it? I think in real time, if you're asking this, in data analysis they use. Okay. If you're going to sort a use list of data, that time merge sort is required. If there is unordered data, complex data, unordered data, then you need to use it.
Sorting is different, searching is different, sir. Sorting means you'll have to arrange. If time permits, yes, I'll cover it. No worries, happens. Sometimes I also mix concepts, don't worry. Okay. One more statement I'll tell you guys. We are taking this time complexities now. Whatever time complexity we are getting, this is nothing but the worst case scenario. What is worst case and all, we'll see later. Okay. All right, then we'll wind up the session for today. I'm getting comments. People are not able to digest more. Okay. I think some people are having 4 o'clock batch right now. Please just continue with the batch. We'll continue tomorrow. Okay. Any doubt is there? Please ask, guys. In real time, if you are going my advanced Java when I'm starting, maybe this upcoming week or maybe next month. Not finalized yet. It will be notified soon. Searching means you're okay. Searching and accessing, someone is asking. Okay, one second. I'll come back to searching and accessing. Before that, let me just complete that. Someone asked me when in real problems when we will go. Suppose, for example, you are having what do we say that? Again, asking another one. Where? Not required, sir. Not required. Listen, if you are taking arrays and you are going to perform sorting, better to go for quick sort. But if you're dealing with the linked list, like yesterday we saw a linked list, there if you're going to do some sorting means I'll suggest you to go for merge sort. Okay. Why, sir, like that? Because quick sort is recursive in nature. It is a tail recursive. You can just search about the tail recursion later. Quick sort will be obviously faster, sir. It is mainly preferred for the arrays only. Yeah, it will perform better. Merge sort is for external sorting, sir. I'm reading everyone's comment. I'm just responding. Sequentially, I'm responding. Please have some patience. Binary search is not a useful thing for unsorted array. I told na. Searching is nothing but going and knocking everyone's door and checking whether your person is there or not. Accessing means directly you know where it is. You directly go to the house where your person is, open the door, bring him and come back. Any other thing is there? Please ask. How is found? Is found is a variable beta. You can change it later. Is found initially I kept as false. So when I said that array of I element present at array of I is same as the target, in that case I'm updating that is found becomes true. Once it is true, after that next line is break. So when this condition matches, when you find the element, then only is found is true. Otherwise it will leave it as false. Yeah, Subham, you can leave if you're not having any doubt, beta, you can leave. Okay, thank you so much, sir, for that. All right, please inform all your friends. Maybe some people would have thought that today some boring topic would have continued. Ask them to go to the videos, today's videos. Is found is not checking whether available, not available. Is found is just getting updated. Later, after the loop, once the work is done, after the loop, you will say, later you will check. If is found equals to true, then you will say system dot out dot println element is present. Else, you'll have to say element is not present. What did Vaishnavi? Anyone else having any other doubt, please ask. No, tomorrow we'll see that. Tomorrow we'll continue with the remaining quadratic time and exponential time. I said na, time complexity depends on the input. Yeah. Yeah, I will share the notes. Yeah, by the end of the day, the notes will be uploaded. You can check it. Same link, everything same. Yeah, tomorrow also we are having class. Tomorrow also same time, 2 o'clock. I'll wait for only 10 minutes. After that, I'll start. At 2 o'clock, I log in. After that, I wait for only 10 minutes. In 10 minutes, whoever comes. After that, I start. So please try to attend on time. Don't enter late and get confusion in the classes by coming late. Because if you'll ask me, I'll have to clear your doubt and it will waste other people's time. So be responsible and come on time so that you'll not miss anything. Okay. Yeah, please ask your other doubts. If you're having any, please ask. Okay, if you're not having doubt, please exit. If you're having doubt, you can ask, sir. Okay, sir. All right then, guys. This was for today. Thank you so much for attending. See you tomorrow at 2 o'clock. Yeah. Bye-bye, guys. Thank you so much. Bye.